So today we are going to discuss, as you all know, about the formation of. We were discussing about the formation of alkyl halide from alkene, and we discussed about that. For example, this is an alkene RCH2 double bond CH2. So this is one hydrogen here. Okay, if I add it in presence of hydrogen halide, this is hydrogen, this halide. So what will happen? The addition product would be formed as we discussed in the previous video. So this will be CH, and the double bond would break first, and the hydrogen will, this hydrogen will get to that carbon which has more number of hydrogen atoms. The negative charge X negative will get to that carbon which has less number of hydrogen atoms. So the X will be attached to this and hydrogen would be attached to this. So this was our product. And what was the rule? If you can recapitulate, what was the rule for doing this? The rule was known as Markovnikov's rule. Markovnikov's rule. So according to Markovnikov's rule, the hydrogen gets attached to that carbon which has more number of hydrogen atoms, and the halide will get attached to that carbon which has less number of hydrogen atoms. But as we can see, as we saw the mechanism of the reaction, it proceeds through the carbocation formation, as we saw, for carbocation formation. And as you know, the carbocation is 3 degrees more stable than 2 degrees more stable than 1 degree. So it is the reason why the product is formed like this. Okay, as we saw in the video. But if I tell you, the another question for you is that if I give you the unsymmetric alkene like this, that RCH and then CH2 in presence of HX, but I will change the reagent and I will add a reagent in this reaction. My reagent is I mean peroxide. I add the reagent, that is peroxide. Peroxide means in which the oxygen bond is, and then here can be R or hydrogen. We can take an example of HOOH, that is hydrogen peroxide right now. So what will happen in this reaction if I tell you the product? So what will happen, that the R will remain as such, and then CH double bond will break into single bond. The bond will break, this bond will break, and what will happen after then, the hydrogen will be attached to that carbon which has low number of hydrogen atoms. It's reverse to the Markovnikov's rule, and the halide will be attached to that carbon which has more number of hydrogen atoms. So this rule is known as anti-Markovnikov's rule. Anti-Markovnikov's rule, or we can call it as Kharasch effect, or we can call it as peroxide effect. So this is the product we are getting in this case, where we take the peroxide with us in the as a reagent. So what happens, what special happens in this reaction, we'll see that in the mechanism. So first of all, we'll see the mechanism of this reaction. So in the mechanism, we'll get to know why the formation of this product happens, why not the Markovnikov's product. So if I tell you the mechanism of the reaction, so this reaction proceeds through free radical mechanism. Free radical, no carbocation is being formed in this reaction in presence of peroxide. It's the special case, and the hydrogen halide is also special for anti-Markovnikov's product. So we'll discuss it later on. Free radical mechanism would be followed. So we will discuss that free radical mechanism. So in first step, what will happen, the peroxide will come. This is peroxide. For example, there can be another peroxide like benzoyl peroxide, or any other peroxide. Here we have taken the hydrogen peroxide, and what will happen, the oxygen bond between them will break homolytically. As you know, the electron, there are two electrons present in this bond. One oxygen will get its one electron, and this oxygen will get its one electron. So what will happen, it will form the odd electron species, that is HO, and there will be a free radical on oxygen. So this will be formed two times. So here is the formation of radical. So when the radical is being formed, what will happen next, the radical, as you know, is most unstable. It will get to HX, hydrogen halide. We can take HBr, hydrogen bromide. Okay, what will happen, the radical makes another molecule break homolytically and will form the radical. Okay, what will happen? The hydrogen radical will be formed and the X radical will be formed. Why? Because of the double bond breaks homolytically. Okay, what will happen? The HO radical will react with this radical, H radical, this radical formed in the reaction. So they will react and they will form HO and H. So this is the water formed. And what will happen? The X radical would be left in the reaction. So the radical has still been left in the reaction. What will happen next? This radical, X radical, will go into what? Will go with alkene, and then what will be formed? As you know that this radical will break this double bond homolytically. This will be break homolytically. Okay, when we break it homolytically, what will happen? The R CH and then CH2, there would be this carbon be radical, this carbon be radical. So in this carbon be one radical, in this carbon be another radical. What will happen? The X radical will attack to the molecule, to the alkyl halide, sorry, alkyl alkyl radicals. But there are two alkyl radicals right now. This is secondary, this is primary, this is secondary, this is secondary, this is primary radical. So there are two cases of halogen radical attacking the substrate. The first case is, if I tell you, the first case is like this: the radical will attack to this carbon radical, or another case is that this radical will attack this carbon radical. So there can be two products formed. The X radical will attack in path, if this is path 1, if this is path 2. So what will happen in part 2? The radical will attack to this carbon, the and lead to the formation of CH, and the radical will be attacked to this, attached to this, and what will happen? The CH2 radical will be as it is. So in part 2, the X radical would attack this CH2, and what will be formed? That is CH, and the radical will be as it is, and CH2 radical will be neutralized by Br radical or X radical here. Okay, these are two types of products can be formed in this attack. So after the attack is being formed, if you observe the radicals well, as you know, the stability of radicals, stability of radicals, you know that 3-degree radical is more stable than 2-degree radical than 1-degree radical. As you have been seen in the carbocation, also the radicals are electron deficient as the carbocations are. So 3-degree carbocations are more stable than 2-degree than 1-degree. So this is the reactivity, or we can say stability order for radicals. So if I tell you, among those two products formed, which is most stable, you can see that here is the secondary radical, here is the primary radical. So secondary radical is more stable, so the reaction will follow this step, or the reaction will follow this path. Not mostly, generally will not follow this path, it will follow this path, because of the formation of secondary radical, secondary radical. And after the formation of secondary radical, as you know, what will happen next? The R CH radical in linked with CH2 and X, and then what will form, what will be formed later on, that X HX radical, HX hydrogen halide will, another molecule of hydrogen halide would be break homolytically. Why homolytically? Because this radicals wants to get stable desperately. So what will happen? The hydrogen will react with this carbon, the hydrogen react with this carbon radical. So what will happen here? The R CH CH and one more hydrogen which comes from hydrogen halide, and CH2 2 and X. So if you analyze this product carefully, and will see, you will see that the radical, oh sorry, the product formed is alkyl halide. But what alkyl halide? It is being formed by the opposite to what Morkonikoff said. So this would be anti-Morkonikoff's product. So this is the mechanism of this reaction. I hope you have understood. We'll do more questions on this reaction. This was simply the concept of the reaction. We have to do some more questions which have been asked in the examination, and which will be asked in the examination. So stay tuned and be with me.